Hello, my name is Tanya Hilton. I'm a 5th grade teacher at Monarch Academy. I'll be working on fluently multiply multi-digit whole numbers using the standard algorithm. So we know that the standard algorithm is a big skill that 5th graders need to learn and master by the end of 5th grade. Now, when I introduced the standard algorithm, I introduced it using two different strategies before we jumped into the actual algorithm. I found that my students needed time to conceptualize and understand exactly what was happening in the standard algorithm before they jumped in and started doing it. So we're going to look at the two strategies that I use when introducing this skill. So we're going to use this word problem to go over the two strategies that I use when introducing the standard algorithm. Tori earns $142 per shift at her new job. During a pay period, she works 12 shifts. What would her pay period for this time be? What would her pay for this period be? So Tori is actually a student in my class, so this would be of high interest. And who doesn't like to get paid? So we know for sure that we have $142 that she's making per shift. And she's been working really hard. So she's worked 12 shifts so far. So we know that is 142 times 12. But exactly what does that mean? So the first strategy I'm using is called Emma. Isn't she so cute? Now you ask yourself, what is Emma? Well, when I introduced multiplying multi-digit numbers, I introduced it using Emma. The first thing you do is you expand your number and you pick one number to expand. Then you multiply and then you finally add in that order. Expand, multiply, add. This acronym was very helpful to my students. So if I had 142 times 12, I would choose to expand the 142. That's a hefty number and I can't do mental math when I'm multiplying. So I'm going to expand that number. So that would work out to be 142. And I'll multiply each by 12 because only one number is to be expanded. 100 times 12 is 1200. 40 times 12 is 480. 2 times 12 is 24. And I make sure that I line up my numbers in the right place value so that it's easy for me to add when I'm ready to add it all together. So right here we have 4. 8 plus 2 is 10 and I carry my 1. 2 plus 1 is 3 plus 4 is 7 and then I bring down my 1. So right here we have 1,704. When I first started teaching this strategy and then I moved on to my second strategy, area model, I found that my students were able to look at the area model and say, wow, okay, I see some similarities here. So another way I started to teach multiplication of multi-digit numbers was using the standard area model. And most of you are quite familiar with this. When I introduced the area model, there was only one change between Emma and the area model in that we decomposed both numbers instead of just one. So I decomposed 142 on the top, and then I would decompose my 12 into 2 and 10. Okay, just like Emma, I expanded my numbers, and now my next step is to multiply. 100 times 2 is 200, 40 times 2 is 80, and 2 times 2 is 4. So my partial product here would be 284. Now down here, 100 times 10 is 1,000. 40 times 10 is 400. And 2 times 10 is 2. So then I got 1,402. Okay, so it's kind of tight in the corner there, so I'm going to bring those partial products down. Excuse my dog, someone's knocking. Okay, then I would add 4 times 2 is 6, 8 times 0 is 8, and 2 plus 4 is 6, and then bring down my 1. Something doesn't seem to be right here. So sometimes when I'm teaching, I will make these mistakes intentionally to see if my students will pick up on exactly what happened. So then we'll go back. Here we go. 100 times 2 is 200. 40 times 2 is 80. And 2 times 2 is 4. So everything looks good here. 100 times 10 is 1,000. 40 times 10 is 400. And 2 times 10 is 20. So that's where our mistake was, 20. So instead of that being 1,402, it'd be 1,420. So within my classroom, I like to build a culture of let's recheck and make sure our answers align. So I will cross this one out and say, hey, I noticed a mistake because my answer should have been the same. And then I bring down my partial product after checking. And then I would write 1,420. Okay, here we go. 4 plus 0 is 4. 8 plus 2 is 10. Carry the 1. 2 plus 1 is 3, plus 4 is 7, and then my 1. Now I can see, oh, okay, everything looks correct. So it's important that even though you're teaching the students the visual model, it's also very important for both strategies that they're going back and double checking their work to make sure that they're coming up with the right answer. And a good way to do that is encourage them to use 2 different models and 2 different strategies to check their work to make sure it looks good. So these are the 2 strategies that I use within my classroom when I was first introducing the standard algorithm. And once we got into the abstract, where I introduced it and began teaching it just like the standard algorithm, my students were able to notice that the partial products were the same. So I hope this was helpful. Bye.